Okay, it's been applied to cancer and so on and so forth. So here's the summary of life, so to speak. It's dominated by these non-linear quarter-power scalings. Non-linear, does not change. You increase, double the size, you get less, you need less energy in a systematic way. This extraordinary economy of scale, the pace of life systematically slows with size, heart rates, lifespans, diffusion of blood across, diffusion of resources across membranes, etc. Growth is sigmoidal, reaching a stable size of maturity, that's predicted by the theory, and it is all governed by networks, and this is a sustainable system. This is totally sustainable. Everything dovetails into each other, into everything. It's spectacular. And we know it. It's been around for over 1 billion years. Now we go back to this question. What about something that happened on this planet beginning about 10,000 years ago? Beginning about 10,000 years ago, we started talking to one another, basically, and interacting and forming little communities and doing things together, ultimately leading to this, what we're doing now, communicating and doing social networking. So it's a new phenomenon. This is a new phenomenon brought to this planet, maybe to the universe, for all we know, in terms of this phenomenon. So the first question, I have no idea what that little beta is doing, but anyway. So the question is, are cities and companies, do they scale? So put it slightly differently. What you discover in biology is that even though the whale is in the ocean, the elephant has a big trunk, I walk on 2 feet, and a shrew scurries around on the palm of my hand, we're actually, to some 90-odd% level, scaled versions of one another. In fact, there's one mammal, and every single mammal on this planet that's ever lived, so to speak, is some scaled version of that idealized mammal. That's the statement, okay? To some 90% level, because I can tell you everything about it once you tell me its size, on the average. Question, is that true of cities and companies? Is San Francisco a scaled-down New York, and is San Francisco a scaled-up Santa Fe, even though they look completely different? Well, you can answer that question by looking at data. So here goes. First, I wanted to remind you of this. And there was a session yesterday, which I'd love to have been to, but you're all familiar with this, that we have this serious problem that everything that we worry about on this planet now, from environment, energy, risk, financial markets, all are urban problems, but urbanization is also the solution because cities are where all the smart people are. They're big vacuum cleaners sucking up creativity. And this is a complete change from when this country was formed, where we had less than 4% were urbanized. Now it's over 80%, and you well know that more than half of the world is now urbanized, and probably in 30 or 40 years, 80% will be. And we don't understand cities in a quantitative, predictive way. There isn't what I consider science-based theory of cities. The question is, can there be? Maybe there can't be. Same goes for companies. So here's the question, do they scale? So here's some trivial thing. This is just petrol stations, gas stations in Europe. And what you see is, God damn it, and there's this population on the horizontal axis, they scale. And in fact, they scale less than linearly. Not surprisingly, there's an economy of scale. The bigger the city, systematically, you need less stations per capita. Turns out, this is true for every infrastructural quantity you want to think of about a city. Now we come to the interesting thing. Those are uninteresting things, actually, even though they're what makes cities work. The interesting things are the new phenomena that started when we talk to one another, socioeconomic quantities. And here are some. Wages versus population on a log-log plot again. And down below, something called super creatives, people like all you lot, okay? Plotted versus size. And what you see is there's lots of fluctuations here, but they scale, and they scale systematically. And most remarkably, the exponent, unlike all of biology, is bigger than 1. all of those exponents, that 3/4, 1/4, etc., all less than 1, economies of scale, bigger than 1. Returns to scale, increasing returns to scale. The bigger you are, the more you have. Bigger wages, more fancy schmancy people, more restaurants, and so on. And we've looked at myriad amounts of data. There's a number of patents over several years in the US. There's police, tax receipts, construction, debt, crime. We've looked at all over the world, everywhere. All of these scale in the same way. This is a remarkable fact, okay? So there's a bunch, there's a data, and I'm going to just summarize what we found. I already said infrastructural quantities that have clear analogs in biology, like gas stations, length of roads, length of electrical cables, all scale in this sublinear way, analogous to biology. The number happens to be 0.8, but they all scale in the same way. The economy of scale is repeated across all infrastructural things. What I call 3 there is what we call superlinear, an exponent bigger than 1, socioeconomic, presumably driven by innovation and wealth creation, those things that I mentioned, everything from police to wages and wealth and so on. And there is just a whole bunch collapsed on one plot showing you that everything scales together. And there actually, I could have put on the plot the GDP for various countries. All have essentially this same 1.15, this magic number. And here's what it says. It says that if, roughly speaking, if you double the size of a city, say from 20,000 to 40,000, or from 100,000 to 200,000, or 1 million to 2 million, or 5 million to 10 million, systematically, income, wealth, number of patents produced, number of colleges, number of creative people, number of police, but also the amount of crime, pollution, and disease, and waste, they all come together in the same way. All by about 15% if you just double the size systematically. Suggesting that these are not independent phenomena, that somehow all of these are connected. Maybe there's a causal connection somewhere here, that you get more innovative, you increase, you get more crime, income goes up, wealth goes up, but coming along with it to the same degree is crime, pollution, and disease. That's what the data say. Okay. So the other thing that comes along with this is, okay, what's the reason for this? Well, this is work in progress, but we believe that analogous to biology, networks determine this. And what are those networks? They're not the infrastructure ones, they're this, doing what we're doing, the multiple social networks and the clustering within those networks, families, groups of families, communities, and so on. And that's the kind of theoretical framework we're working on. But independent of the details of that, here's what comes out of it, is that as in biology, where we had it's not working, the beta less than 1, the exponent less than 1, sublinear, pace of life increases systematically with size. If social organizations are driven by superlinear scaling, creativity, wealth, creation, and so on, with an exponent bigger than 1, then systematically the pace of life increases with size. It goes exactly the opposite. So the bigger you are as you grow and expand, things get faster and faster. And I just throw an amusing example here. On the left is heart rate. On the right happens to be walking speed. Can you believe it? I mean, this is taking this to extreme. But it's been measured, and there it is. The exponent is a little lower than we predicted, but nevertheless, it's remarkable that somehow that social networking actually takes place maybe at some subliminal level, even as you walk. Okay, now I don't have time in this. We are in the middle of doing a whole bunch of stuff on corporations, companies. And we have the data for all publicly traded companies in the United States going back to 1980, and we have other data going back to the 50s on companies that are publicly traded, and we've asked about their scaling. And I'm just going to show you one thing here, And we have all the data actually mostly comes from through the IRS, through tax returns. So the only one I'm going to show you is the one on this damn thing. The one on the left is the one top left is the one I showed you on income for cities. This is companies. This is preliminary data on companies. And it's total, one is assets and one is income. And you can see they scale. And in fact, the one at the top right is Walmart. And you can see they scale. That is, you give me the size of the company, I can tell you, roughly speaking, what its assets and income is. And I can tell you 20 or 30 other things about that company in the same way I could about the animals and so on. And what is intriguing is it scales when it gets large, like biology. And no doubt that has some relevance to why all those companies, including Walmart, are going to collapse at some stage. All companies die. We know of almost very, very few companies that existed for more than 300 or 400 years. There was very, very tiny companies. They're mostly breweries, incidentally. The only one that existed longer than that is the Vatican, which I do consider a corporation.